Welcome back to Further Solutions Academy. Further Solutions Academy. Don't forget to share our video to your friends. Subscribe if you have not subscribed before. At this point, we have a lot of videos for you. You can play with mathematics, physics, and chemistry. On this video, I'll be walking you on the elasticity property of solid. By the end of this video, you will understand what is called, I think the outline should be the outline. We have what is called Hooke's law. Hooke's law, and not laws. Second one, we're talking about Young modulus. And we talk about with the help of theory, we'll be talking about tackle, and we'll be talking about strain and stress, and also we'll be talking about work done in springs and elastic spring, and also we try to work on examples. Now, what I want you to know is that at this point, this particular one example, I may not be able to do much example on this video. It means be expecting more videos on. Okay, back to what I'm saying. Now, by the next video, I will do more examples. It means on this video, I will not do more. I will name emphasis on these examples. It means I'm having two videos on the elastic property of solid. That is what we have to work on. By the end of the video, you will surely understand all this. Okay, let me start the program. Now, let me start, and don't forget to share to your friends. We'll be having a very lovely video. Okay. Now, let me state Hooke's law for you. Now, okay, you can see Hooke's law states that the change of extension, which is E, of an body is directly proportional to the applied force, which is F, provided that the elasticity limit of the body is not exceeded. By force directly proportional to what? Extension. It means by force directly proportional to what? The E, which is F. Now, when you have this proportion, it means you apply a constant K. This is a constant K. Now, by so doing that, it means my K is a force constant, or stiffness, stiffness of the material in Newton meters, per meter. And my force is equals to my force, which is my F, is equals to force or weight in Newton. You know what is called weight. Now, whenever you see force, my force is also denoted as what? Mg. My mg means mass, which is mass in kg, and this g means acceleration due to gravity. Acceleration due to gravity, which is a meter per second squared. That is what you need to know about Hooke's law. Now, let me try to work on the second one, which is known as Young modulus. Okay, let me explain Young modulus. It's a very simple part of it. Young modulus, which is going to be, normally we only denote this by Young modulus, is defined as the ratio of tackle stress to tackle spring. That is what Young modulus is saying. Now, it means my Young modulus equals to what? Tackle stress all over what? Tackle. Now, by so doing that, you really understand what is called Young modulus. Now, let me explain what is called tackle. I think you need to understand. Tackle strain is the ratio of the extension of a material to its original length. Now, a strain equals to change in, sorry, this should be change in length all over original length. Now, which is extension, or you can call it a compression, extension or compression all over what? Original length. It means this is denoted by what? By E, which is extension all over what? The length. That is what we mean by what? Tackle. Let me use this opportunity to explain what is called tackle stress. Tackle stress. Now, okay, let me explain what is called tackle stress. Tackle stress is the ratio of the force acting on the material, to the cross-sectional area of the material. Now, it means my stress equals to force all over area. It means this is my force, this is my area. Now, for instance, area of a circle, let me use a circle as a very good example. My circular area is pi half squared, which is going to be force. And therefore, my Young modulus, it always equals to what? The stress all over what? The strain, which is going to be what? Now, it means I'm saying that what? My F divided by A also E divided by what? E. I think you know this in elementary mathematics by saying that A multiplied by E all over what? E. Now, that is how I have my FL all over what? AE. Now, it means my force times length all over what? Area extension. That is what I mean by that. Now, the SI unit, which is the unit of it, the SI unit for Young modulus is Newton per meter squared. Newton per. I also am allowed to write this as Newton all over what? Meter. Or some people will do it like this, anyhow you want to say it, or you do it this way. Normally, mathematically, this is not acceptable, but in physics, is allowed. Now, which I can also say that Newton per meter squared. Now, that is all what you need about that. Now, before I end this part, let me use this opportunity to explain what is called sorry, permit me to explain what is called work done. Sorry, work done. Now, let me explain what is called work done. Now, if I'm talking about work done, okay, now let me try to explain work done. Now, work done in a springs and elasticity springs, in a spring and elasticity springs. Now, if an applied force, which is F, caused an elasticity spring of original length, which is L, to undergoes an extension or compression, which is going to be E, then the average force will be equals to what? Which is, I've told you that to find any average of a given thing, you have to find the final and what? Initial, which is divided by the what? The total, which is divided by 2. Now, final, initial, which is going to have that, plus this is going to be divided by 2, which I have this. It means the average of it is going to be what? Force divided by 2. Now, my work done is always, you all know that in the normal physics, our work done is always equals to force times distance. Force times distance. And at this point, my work done will be average force multiplied by what? Extension. Average force multiplied by extension. And you know what my average force is? My average force is talking about what? My force all over 2, which I've done that here. Extension is E. Now, by so doing that, my work done will be equals to what? 1 over 2 Fe, which is by multiplying them. Now, this will be equals to this, and this will be equals to this. And you know that my force is equals to what? Ke, which is, I have it in square, I have that in square, which is 1 over 2 there. Now, the same thing that will occur to energy. Thank you. I think this is work done by the spring, when compressed or extended by the what? By the force. Now, I just said that what? The energy stored in the spring or a spring is also given by the what? Work done all over this, which is also the same thing as this. When I'm using my F, I will have Fe. But once I switch to K, because I've said it at the beginning that my F is equals to what? Okay, My F is equals to that. Now, which I will switch that, which I will be having that. We all know what is called the SI unit of joule. Of energy is what? It's joule. Now, please take note of this. Then let me now try to give one or two examples to illustrate my point. Now, one or two examples to illustrate my point. Now, I'm now on problem. I've explained what you need to understand on this part. Okay. Okay, now let me try to give example, which is, let me call it problems or examples. Examples. Now, the first example let me look for a question. Okay, now I have some question here. Okay, let's work on this question. Okay, a very simple one. Let's see, it can come out anywhere, in JAM or WAEC. An object weight 0.6 Newton is hung on a spiral spring and causes it to extension by 6 centimeters. The object is moved and a block of wood replaces it, causes the spring to extend by 10 centimeters. What is the weight of the block of the wood? What is the weight, of the block of the wood? Now, by so doing that, okay, now, the next thing I need to do now is that I have to let you know what you need to work on. Number one, I have what is called applied force, which is going to be F. I have it as 0.6 Newton. That is very first one. Now, the next thing I'll be looking at is that I'll be working on. Now, the next thing I'll be having is that I'll also be talking about the extension, which is going to be E, is also the same as what? The extension will be equals to. Okay, now. My extension is equals to, what is my extension from the question? It will be equals to 6.0 centimeter. And the next thing I need to understand here is that I need to convert this to it to be 0.0 meter. That is the conversion. This is centimeter and this in meter. Now, the next thing I need to work on, I will now say that therefore, my force constant, which is going to be K, will be equals to F all over what? E. F all over, force all over extension. What is my force? My force is 0.6. 0.6 divided by, my E is 0.06. Now, which I will be having, by so doing, this is going to be 10 Newton. Yes, it will be 10 Newton per what? Per meter. 10 Newton per meter. Now, since I have that, I can also say that weight of the wood, which is going to be F equals to what? KE, which also the same thing as what? Multiplied by 0. Is 0. Okay, before I do that, I must to generate my what? My E. Okay, now I need to generate my force on E, which is I'll be having 10, which is I will convert this to what? Meter, which is going to be centimeter, which is going to be 0.1 meter, which I will now say that what? My K will be equals to 10 Newton per meter. Now, since I have that, my weight of wood will be equals to force KE, which I'll be having 10 multiplied by 0.1, which I'll be having it will be equals to 1. That is equals to 1 Newton, 1.0 Newton. That is what I am to work on. That's what I'm to work on. Now, I think this is very clear. Take note of that. Now, another question that can also come up. Let me try to generate another question. Okay, now look at this question. Now let's see this one. And load a load of 5 Newton give an extension of 0.5 centimeter, 0.56 centimeter in a wire, which obeys Hooke's law. What is the extension caused by a load of what? Of this particular amount of number. Now, how do I solve this particular question? It's very simple. It's very, very simple. Now, the first thing I need to know is that applied force, applied load and the force, which is going to be what? 5 Newton. It will be 5 Newton. Now, and extension will be equals to which is going to be E, it will be equals to 0.56 centimeter. And force constant, which is going to be also on the important part. Force constant will be equals to KF all over E, which I will be having 5 all over 0.56, which it will be equals to what? 8.93 Newton per meter. That's what I'm going to be having. 93 Newton per centimeter. Sorry, I think this should be per centimeter, not per meter, because of this is seen in centimeter. Now, since I have that, I can answer that what my force of 20 Newton now will be my K will be equals to 8.93 Newton per centimeter. Now, which I will be having that, it means my extension will be, which is going to be E, will be F all over what? K, which I'll be having 20 divided by 8.93, which I'll be having 2 centimeter. That is going to be, yes, that is all about that. That is all about that. Now, lastly, before I end this session, let me try to show one very powerful one example also more. Last example. Oh, this is not really very well. Now, look at this question. Now, look at this question. Let's try to work with it. And a spiral spring balance is 25 centimeter, 25 centimeter long. When 5 Newton hands on it, and 30 centimeter when the weight is what? 10 Newton. What is the length of the spring if the weight is 2 Newton? Assume Hooke's law is what? Obeyed. Now, this is a very nice question that you need to understand very well. Now, you need to understand the concept very well. Now, I need to work on now is that the first thing I will let you know is that length. Let the original length. How do I call it? Original length be okay, of the spiral spring BL. And we all know that my extension is which is going to be E, is always equals to new length resulting from applied force minus original length. Now, at this point, I will generate some cases because there are two cases here. This is the first cases and this is the second cases. Take note of that. Now, I will just have it in form of what? First case, case 1, or first case, extension which will be E will be equals to 25 minus what? 0.0 centimeter minus L. That is the first case. Now, we all know that my force is equals to what? My force here is equals to 5 Newton. Now, since my force is equals to 5 Newton, and I think that is very correct. Now, my second case, which is going to be second one, will be extension, which is going to be E, will be equals to 30.0 centimeter minus length, which my force there is equals to 10 Newton. That is very first thing I will do. Now, I will now come back to the normal, which is my F equals to KE. My force equals to KE. Now, let me try to substitute into first and second cases. Now, it means what I'm trying to do now is that I will have this as that my force, the first case will be the first one now. It means I'll be having my force, which will be 5 Newton equals to 25 minus L bracket of what? What is my E? Bracket of K, that is my E. Bracket of K, I can call it equation 1. And also I will have my 10 equals to, I have 30 minus L bracket of what? K, equation 2. Now, by so doing that, I think I'm doing the right thing. Now, by so doing that, I can now move on by having, the next thing I need to have is that I will just have my K equals to 5 all over what? 25 minus L, and my K of second one will also be equals to 10 all over 30 minus L. Now, this is L, sorry. Now, it means K equals to K. Now, 5 all over 25 minus L will be equals to 30 all over 10 minus L. Year 1, year 2. Now, I think I'll be having 30 minus L multiplied by 1 equals to 2 bracket of 25 minus L. Now, which I will be having 30 minus L equals to 50 minus 2L. Now, can I correct like times? I'll be having, this is the L, not 2, sorry. I'll be having that. Now, it means I'll be having minus L plus 2L equals to 50 minus 30. We have 20, and this is going to be L. It means my L equals to 20. My L equals to 20. Since my L equals to 20, I can answer that what? Extension E of the first one will be equals to, which is first case, which is going to be first case. It means I'll be talking about 25 minus 20, which it will give me 5.0 centimeter. It means 5.0 centimeter. I will convert this to, which is my A will be 0.05 meter. That is going to be, this is equals to this. We all know that. Now, the second one, which is going to be now, since I have that, yes, hope I'm not doing it. Now, I will now say that what apply force on now applied force, which is going to be 5 Newton. Now, it means I'll be having my F equals to KE, and my K will be equals to F all over E, which I'll be having 5 all over 0.05, which is it will be equals to 100 Newton per. Now that is what I'm going to be having. That is what we are going to be having. Now I will not say that what my okay, the next thing is my E will be equals to force all over K. My force all over K. Now we all know by K, our K is 100. Our force is what? Is 2. Our force is what? 2, which is this. It means I'll be having E equals to 2 all over 100. Now, which I'll be having 1 over 50. 1 over 50, the same thing as that. It will be E will be equals to 0.02 centimeter, which also the same thing as what? 2 meter. That is, this will be meter, which is same thing as what? 2 centimeter. Now that is going to be. Now I will now say that what? New length of the spring equals to original length, which will be L. Please put it as L plus extension, which will be E. It means I'll be talking about what? It means I'll be talking about what? 20 centimeter plus 2 centimeter, which I'll be having 22 centimeter, or 0.22 meter, either of the two. That is what we are trying to. What is the length of the spring if the weight is this? That is the length. So that centimeter in what? Oh, I think I'll be stopping here for now. Don't forget you are home with Further Solution Academy. Once again, thanks for watching. On the next video, I will solve more problems on this particular part of physics. Thanks for watching.